right. So section 1.2.2, we're going to talk about histograms. So a histogram is a way of displaying a distribution for a quantitative variable. It looks almost like a bar chart in that there are still bars, but it is not a bar chart. They are very different. Bar charts are for displaying categorical distributions, and histograms are for displaying quantitative distributions. So let's get to it. All right, so how to make a histogram. You're going to divide the data into classes of equal width, find the count, sometimes we call that frequency, or percent relative frequency of individuals in each class, and then label and scale your axes and draw the histogram. The height of the bar equals its frequency, and that should say or relative frequency depending on which scale you decided to use. Adjacent bars should touch unless a class contains no individual. Couple things. So sometimes we call the classes that we divide these into bins. Sometimes we call them buckets. All right, so let's try this. So here I've given you a frequency table, and it presents data on the percent of residents from each state who were born from outside of the US. So there's 50 total pieces of data. And so we've already labeled and scaled our data. We've already created our bins. Notice that our bins, or our classes, are 5 percentage points wide. And now we're ready to actually create our histogram. So if I'm doing this by hand, first thing I'm going to do is note the count in the first class. 0 to 5 is 20. So I want the height of that rectangle to be at 20. There we go. So next, the count of states that have 5 to 10% foreign-born citizens is 13. So I'm going to place my height at 13. Draw my second rectangle. All right. States with 10 to 15% foreign-born is at 9. I'm going to draw that at 9. And then 15 to 20% foreign-born is at 5. I'm going to draw that at 5. And then finally, the last two, 20 to 25 is at 2. And then 25 to 30 is at 1. So generally it's understood that the right-hand endpoint is non-inclusive, meaning if a state had 5% foreign-born citizens, that state's data would go into this bucket, the 5 to 10. If a state had 10% foreign-born, that state's data would go into this bucket. So that's what I mean by non-inclusive. That right endpoint is not included in that interval, unless otherwise stated. All right, couple things to note. Make sure you both label and scale your X and Y axis. So as I said, the key difference between a histogram and a bar chart, histograms are for numerical data, quantitative data, whereas bar charts are for categorical. And the reason we don't put gaps in between the bars on a histogram is that the x-axis, the horizontal axis, is a continuous number line. All right. Versus in a bar chart, there are gaps because they just represent, the x-axis will just be categories of some kind, like color, some other categorical variable, like that. So let's move on. I'm going to show you how to do these in your calculator in a second. First, some cautions. Don't confuse histograms and bar graphs. We just talked about that. Don't use counts or percents as data. You'll want to use percents instead of counts on the vertical axis when comparing distributions with different numbers of observations. And just because a graph looks nice, it's not necessarily a meaningful display of data. So that's going to go with, there's a little bit of an art to histograms, because a lot of times you have the choice about how wide your classes should be. And so you need to make that decision based on getting the most reasonable picture of the overall distribution. We'll kind of talk, I'll show you some examples and counterexamples with that. All right, I'm going to shut my camera down and just talk to you, because when I pull my calculator up, my computer sounds like it's going to explode if I also have my my face framed in the camera as well. Okay, so I'm going to show you how to create a histogram in your calculator, and then we will copy that over to our paper, because this is what you would have to do on an exam. You can make it in your calculator, but you can't exactly turn in your calculator with your exam, so you're going to be copying it over, and I'm just going to be noting what is important to put in there. So this is just a list of the average points per game for all of the teams in the NBA for the 2012 season. And I just want to make a histogram to display the distribution. So we're going to pull up our calculator. And the first thing we want to do is go to Stat, Edit, and that's where the lists are that we can enter data. So in list 1, we just want to enter all the data. So all of the team's average points per game. So I'm just going to take a minute, I'll pause it and enter it in here. Okay, so there we go. I've got all my data entered. A couple things to notice here. There's 30 teams in the NBA. Right next to the cell, when you highlight a cell below that, it'll display the value in that cell, but it'll also tell you what cell you're on. So I'm on cell 30, so I know I've entered 30 pieces of data there. All right, so I did want all of those in list 1. I'm just going to scroll back through and make sure I didn't miss a decimal. It all looks pretty good. Okay. So next thing we're going to do, I'm actually going to turn on, let's see. That's not what I want. Sorry, there's a way that you can turn on the key press history. Hey, there we go. Okay. So now down here, you should be able to see my key press history. All right, so I'm going to go to, well, first thing I want to do is go to y equals, and if there's anything in there, clear it out. Okay, you don't want algebraic graphs graphing over your statistical plots. It can get confusing. So next thing I'm going to do is go to second y equals, and these are where your stat plots are located. So I'm going to go into plot 1 and turn it on. And then I'm going to select the type of plot I want. So the first one's a scatter plot, second one's a line plot, and the third one is our histogram. I'm going to choose that. This is where you tell it where your data is. So my data is in list 1, so I'm going to keep it there. If your data was in list 2 or list 3, there are shortcuts to list 2, list 3, list 4, list 5, list 6, just down here on the numeric pad, and you can get to them by pressing second and then the number that it corresponds to. Frequency we leave as 1. Color, this is where you get to really be you and be creative. Ooh, magenta. Okay. So I'm then gonna quit to the main screen. We're gonna go to zoom, and the 9th option is zoom stat, and that'll at least give us a starting point. There we go, we have a histogram. So before we start copying this down onto our paper, a couple things I need to show you. First, if you hit trace, it will put your cursor on the first bin, and it will tell you how wide that bin is. Notice that, like I said, by default, the right endpoint is non-inclusive. So this bin is from 93.2 to 95.35, but strictly less than 95.35. So if a team had an average of 95.35, they would actually go into the next bin over. And then n equals 10. That's telling me how many pieces of data, or the frequency that that bin has. So that's how tall, essentially, that rectangle is. So I can then scroll to the next bin over, and it'll continue to tell me the endpoints in the bin and how many pieces of data fall in that bin. All right, let's say the computer just kind of defaults for you. It'll give you a pretty decent number of rectangles. But maybe it doesn't make sense to have your endpoints be decimals. Let's say you wanted your endpoints to be whole numbers and you wanted to specify a different bin width. So this is how we're going to do that. You can change that in the window menu. If I hit window, this is going to be where all your options are. So a couple things to point out. Creating a histogram is a little bit of an art. You don't want too few rectangles because that doesn't show you enough. You don't want too many rectangles because that also has the opposite effect. And I always use the analogy, it's like going to an art gallery and viewing a piece of art, right? You don't want to put your nose up against a painting, but you don't want to stand 300 yards away from it because then you wouldn't be able to see the detail. So there is kind of this happy medium. So when you're making your decision, you're going to make it based on the raw data usually. So I'm going to go back to our raw data and take a look here. Everything's in the 90 to kind of lowish 100s range. It looks like what's our lowest? Our lowest value is like 93.2, and our highest points per game average is what? 106, it looks like, 106. 106.1. Okay. So if I think about the range of values there, that can kind of help me make a decision. So let's say I want my bins to go by 2s, because basketball, you score by 2s. And I want to make sure to include all the data. So I'm going to go from 92 to a max of 108. And this X scale is what actually is your bin width. So the calculator defaulted to making our bin width 2.15. I just want it to be 2. And then you might have to change your Y max, because now that we've changed how many bins there are, our bins might be taller or they might not be as tall. So you might not need to see as high. I'm going to keep the Y min negative. You don't need to, but that just gives you a little margin so your graph isn't starting right at the bottom of your calculator screen. We'll make the max, I'll say 10, and then we can adjust if we need to. So then I'm going to hit graph. All right, and I'll hit trace one more time. And good, now you can see my bins. Endpoints are whole numbers like I wanted. So from 92 to 94, and there's 5 pieces of data there, 94 to 96, 6 pieces of data there, and so on. This is a decent one, and I think we can copy this one over. But before we do, I'm going to show you some bad ones. So As I said, it's a little bit of an art. You don't want too many rectangles and you don't want too few. Too few rectangles, let's give that example. What if I made my X scale, my bin width is now like 30 points. I'm gonna have to make my Y max way taller. Oh, cool. We have one bin, one big rectangle. That doesn't really show us anything, right? That just says that all teams scored between 92 and 108 points during the 2012 season. That doesn't show me any of the variability from team to team. So there's too few bars. Let's do one that's too many. What if I make my bin width really tiny? What if I make it like 1 point or 0.5 points? And I'm going to need to make my scale really short, like 3. So that's kind of the opposite effect. That's way too many bars. You have a bunch of gaps here because you made way too many bins with way too much granularity. So what's the rule? There isn't really a hard and fast rule. The rule of thumb is somewhere between 5 to 12 bins total is usually good. But I'm going to go back to the one that we did, which was 92 to 108. Our bin width was 2, and our Y max was 10, and that gave us a pretty good look, right? Great. So then you're going to copy this over. I'm going to use the magic of computers to do that. Okay, so by the magic of computers, I was able to transfer the calculator one onto my paper. You would have to just sketch it out. It doesn't need to be perfect, but you should make an effort. Try and use a straight edge if you have one. But now what does need to happen is we need to label all the pertinent information. So first thing I want to remember is how wide are my bins? They start at 92. Okay. And they are too wide. So we will label that first. 94, 96, 98, 100, 102, 104, 106, 108. Then we need to provide context, so we need to give a label to that x-axis. So I'll say 2012 NBA average points per game. All right, and then we're going to scale the y-axis. Bring the calculator back. You don't have to scale it super consistently. This first one is 5, so I'm just going to scale 5. And 6. All right. So 1, 2, 3, 4. Oops. Let's offset there. 6, 5, 4, 3, 2, 1. And then I'm just going to label that side as frequency or count. And that's it. That's all you need to get full credit on a histogram. So, for you guys, there's a student example that I'd like you to go through. Give me 1 second to pull back up my slides here. And I'm going to have you work on this one. Oh, I forgot to make an important point. once you have the, well, two important points. Whether you use frequency or percent, so relative frequency, that's not going to change the shape of your histogram. That just changes the scale of the y-axis, so it'll still be the exact same shape. The other thing is now we can kind of just view these histograms the same way we did dot plots to describe a distribution. So you can think of kind of drawing an imaginary, what I call the density curve over it, so to represent the overall shape of the distribution. So our points per game would have a clear right skew, right? And you would say the mode is somewhere between 93 and 95 points per game. And you would want to talk about spread, so you could talk that the range is from 93 to 107 points per game. And add context, so just making sure that when you're describing the distribution, you're actually describing it in terms of average NBA points in 2012 and not just describing it as abstract numbers. With that in mind, you're going to make a histogram in your calculator and copy it over onto a piece of paper. I am going to have you scan and upload for me, so this will be kind of your accountability piece. So I'll give you space to do that. And this data is going to be on carbon dioxide emissions per person from countries with populations of at least 20 million. So you're going to make a histogram, and then you're also going to describe it using that SOX acronym for me. So shape, center, spread, and if there are outliers, describe them, making sure that you do that in complete sentences and provide context. So here you go, there's your actual raw data. This is all one list of data, so you'll want to enter all of it into list one in your calculator. It's okay to just use the calculator's default buckets, but you still need to label your histogram. So go ahead and do that, and we'll go over it in our next class. All right, folks.